So let's go to the third concept. Now here we have to find out in how many ways can I express a number as a product of two co-prime factors. If you remember, we had discussed co-prime in the first class and in also the second class. Co-prime basically are two numbers which do not have any common factor between them, or the HCF of two numbers is 1. When the HCF is 1, they are basically co-primes. Okay, so this is a very simple answer. If n is equal to a to the power p, b to the power q, c to the power r, ABC we already know. We are using a new term here, n. N is the total number of distinct prime factors. N is the total number of distinct prime factors. Let's say I take the number 120. Okay, 120 is equal to what? 260, 230, 215, and then 3, and then 5. So it will be written as 2 cube into 3 into 5. Okay, so here I have 2, I have 3, and I have 5. So n is equal to 3 in this case. N is the count of number of distinct factors. It has nothing to do with the power. You have 2, 3, and 5. So n is equal to 3. Okay, so the answer is very, very simple. Total number of pair of co-primes is 2 to the power n minus 1, which in this case it will be 2 to the power 3 minus 1, or 2 to the power 2, or 4. There will be 4 pair of co-primes. Now why the answer, normally this answer will be a very small number, and why such a small number, remember, is because your 2 cube will always move together. If any part of 2 cube goes in the first factor and any part of 2 cube goes in the second factor, then they will have 2 common. So that's why it doesn't depend on the power. So this number basically, if you have to represent as a into b, okay, and very interesting, then you basically have 1, you have 2, and you have 3. You have 3 parts. Okay, so first case will be you take 1 on one side and you take 2 cube into 3 into 5 on the other side. So this is a pair. Then you take 2 cube on one side and you take the remaining on the other side. Then you take 3 on one side and you take the remaining on the other side. And then you take 5 on one side and the remaining on the other side. These are the 4 pairs. 1 into this is the first pair. 8 into this is the second pair. 3 into this is the third pair. And 4th into this is the 4th pair. So basically it means 1 into 120, 8 into 15, 3 into 40, and 5 into 24. These are going to be 4 pairs of co-prime factors. Okay, so that is the answer. So as you can see, the value does not depend on the power. Higher the number of distinct prime factors, higher will be the value. Okay, and the value, so as you saw, there are 3 distinct prime factors. Now if there was a number 2 into 3 into 5 into 7 into 11, now though this number may not be very big, 5 into 2 is 10, 10 into 3 is 30, 30 into 7 is 210, 210 into 11 is 2310. So 2310, but the answer for this would be 2 to the power 5. Now the n is equal to 5 here, right? 1, 2, 3, 4, 5. So it will be 2 to the power 5 minus 1, or 2 to the power 4, or 16. It will have 16 pairs. Okay. And also remember that the answer includes 1 into n. Okay. 1 into 120 is included. Okay. Simple concept. Let's do a question on this. For the number 3600, in how many ways can the number be written as a product of two numbers which are co-prime to each other? 3600 we had factorized. What was the factors? 2 to the power 4, 3 square, 5 square. So 3600 is equal to 2 to the power 4 into 3 square into 5 square. So the answer will remain same as number 60 that we just saw, because n is equal to 3 here. And as I told you, this answer depends on n. So answer is 2 to the power n minus 1, which is 2 to the power 3 minus 1, which is 2 square, which is equal to 4. What will be those 4? Again, first will be 1 into 3600. You take everything on one side. Second, you take 2 to the power 4 on one side, which is 16 into the balance. 3 square is 9, 9 into 25. So 25 into 9 is 225. Then you take 3 square on one side, which is 9. So 9 into 400. And then you take 5 square on one side, which is 25. And then you have 16 into 9, 144. These are the 4 co-prime pairs. Okay, as simple as this. Okay, let's look at one more, and here also this concept of co-prime applies very beautifully. The HCF and LCM of two numbers, HCF, LCM we had done in the last class. If you have not done that, please go back and revise. We are going to use that concept here. The HCF and LCM of two numbers A and B is 18 and 2268 respectively. Now if the HCF is 18, number A can be said to be 18x, number B can be said as 18y, and the LCM will be 18xy, which is equal to 2268. So xy is equal to 2268, I will divide by 18. So you will get 1, then you will get 46, 36, then 10, 108. Xy is equal to 126. Okay. And if you remember, we had discussed that x and y should be co-primes. X and y should be co-primes. Okay. So this boils down to the same question, that 126 has to be broken into two factors such that they are co-prime, and that's where this concept applies. Okay. So these factors will be applicable in so many different questions. Okay. So 126, let's factorize. 126 is equal to 2, then you'll get 63, 3, you'll get 21, then again 3, and then you'll get 7. So it is equal to 2 into 3 square into 7. So that means n is equal to 3. So number of co-prime pairs will be 2 to the power 3 minus 1, or 2 square, or which will be 4. There will be 4 pairs. What will be those 4 pairs? That also is very simple. It is 1 into 126 first. It is 2 into 3 square into 7. 3 square is 9. 9 into 7, 63. Then it is 7 into 9 into 2, 18. And then it is 9 into 14. Okay. So these are the possible values. Fine. So the number, remember your number A and B, this is x and y. X and y or y and x. So your number will be multiplied by 18. So A will be, you multiply with 18 and you'll have the number. So how many pairs are possible for A and B? 4 or 8? Answer would be 8. Remember, because how many pairs, and it specifies A comma B. Okay, so it's an ordered pair, and when it's an ordered pair, what I mean by that is A, B, first A can be 18 into 1, B will be 18 into 126, also A can be 18 into 126 and B can be 18 into 1. Okay, so each one will have two values, x can be 1 or y can be 1. Similarly, A can be 18 into 2. In that case, B will be 18 into 63. Or B can be 18 into 2 and A can be 18 into 63. So similarly, each one of them will give you two possible combinations because it is x or y and this is y or x. Hence, there will be 8 values. Okay. Then the second question is, find the minimum possible sum of A and B. Now obviously A plus B is equal to 18x plus y. So the sum will depend on x and y. So x plus y, if you see here, 1 plus 126 is 127. And as you go down, the value decreases. Last one is 9 plus 14, which is 23. That is the least that you get. So it is 18 into 23. Which is how much? 8 into 3, 24, 2 carry, 3 plus 2, 5, 5 plus 16, 21, 2 carry, 4, 1, 4. So the answer is Choice D, 414. Okay, so this concept of co-prime pair is also used in these questions. Very, very useful. So one very nice application of this concept. Okay, let's come to the fourth part now. And here we are dealing with sum of factors now. Okay, and this comes from your binomial theorem, and we use those concepts. Don't worry too much. Just remember this, that sum of all the factors is equal to a to the power p plus 1 minus 1 upon a minus 1, b to the power q plus 1 minus 1 upon b minus 1, c to the power r plus 1 minus 1 upon c minus 1, and so on. And obviously the sum includes 1 and n, the number itself, because they are counted in the factor as well. Okay, let's take a small number so that I can explain this to you. We had taken a number 60 some time back. Okay, 60 is equal to, where did we take that? We've taken 120. Okay, 120 is 2 cube into 3 into 5. Let's take 120 only. So 120 is equal to 2 cube into 3 into 5. Okay, let's apply this formula here. So sum will be equal to, and it looks complicated, but it's not a complicated formula. So it will be 2 to the power 3 plus 1, which is 4, minus 1 upon a minus 1, which means 2 minus 1. Okay, then 3 to the power 1 plus 1, which means 2 minus 1 upon 3 minus 1, and then 5 to the power 1 plus 1 minus 1 upon 5 minus 1. That is what you get. So 2 to the power 4 is 16, 16 minus 1 is 15, 15 by 1 into 3 square is 9, 9 minus 1 is 8, 8 by 2 into 5 square is 25 minus 1, 24, 24 by 4. Okay, remember here that the numerator will always be divisible by this, because we had discussed in one of the earlier classes also that a to the power n minus b to the power n is always divisible by a minus b. And 1 has no power. You can assume this power also to be p plus 1. So it is of this format only. So you can see that 8 is divisible by 2, 24 is divisible by 4. That will always happen. So this is 6. This is 4. So 6 into 4, 24. We have 15 into 24, which is 360. So the sum is 360. Okay. Now let's check this manually also. And that is what I wanted to show. What are the factors of 120? We have 1, 2, 3, 4, 6, 8, 10. Right, total factors were 4 into 2 into 2, 16. We have written how many? 1, 2, 3, 4, 5, 6, 7. Eighth one will be 1, 2, 3, 4. We didn't take 5. 5, 6, 8, 10. Now you have 12, you have 15, you have 20, you have 24, you have 30, you have 40, you have 60, and you have 120. These are the 16 factors. Okay, let's manually add them. 1, 2, 3, 4 is 10. 5 plus 6 is 11. 11 plus 8 is 19. 19 plus 10 is 29. This is 29. I'm just making parts of 4. Then if I add here 4, 5, 6, 7. 7 plus 4, 11. 1. 1 carry. 2, 2, 4, 5, 6, 7. I have 71. And these 4, you have 0, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 5, 1 carry, 250. Okay, now if we add these parts, 29 plus 71 is 100, 100, 110, 110 plus 250, you get 360. So that is what is the sum of the factors. Okay, simple. Let's apply this. So we have number 2160. 2160 we have factorized earlier also. What were the factors? 2160 we had taken here. Yeah. 2 to the power 4, 3, 2, 4, 3 cube, 5 to the power 1. So these are the factors. Okay, find the sum of all the factors. So obviously my sum is going to be 2 to the power 5 minus 1 upon 2 minus 1 into 3 to the power 4 minus 1 upon 3 minus 1, 5 square minus 1 upon 5 minus 1. Okay, which is 2 to the power 5 is 32. 32 minus 1 is 31 by 1 into 3 to the power 4. 3 to the power 4 is how much? 81. 81 minus 1 is 80 upon 2 into 5 square. 25 minus 1, 24 by 4. Okay, so this is 40. This is 6. So it is 31 into 40 into 6, which is 31 into 240. How much is this? 240 is 2400, 7200, 7440. This is the answer. Fine. This is a direct application of the formula. Second is a very interesting application. If all possible sizes of football fields are made with length A and width B such that A is greater than B, so length is greater than the width, and A into B is equal to N. A into B is equal to N. That means A into B is equal to 2160. Then what will be the sum of the perimeters of all such fields? Okay, so interesting question. So basically A into B is your product of two factors concept. Then we want the sum of the perimeter. Now if you have a football field A into B, I hope you remember the sum of the perimeter is 2 into A plus B. Right? So now if I have A1 into B1 is 2160. Second is A2 into B2 is 2160. Third is A3 into B3 is 2160. Let's say there are only three cases, there are only three pairs. Then sum of the perimeters of all such fields will be 2A1 plus B1 plus 2 times A2 plus B2 plus 2 times A3 plus B3, or I can take 2 out. It is A1 plus A2 plus A3 plus B1 plus B2 plus B3, right? And these are nothing but the sum of factors. Right? These are nothing but sum of factors. Okay, so the answer for this is nothing but same as the previous answer. You just have to do double of that. So this answer will be 2 into 7440, which will be 14,880. This is the answer. Okay, so very nice application of that concept. So this answer is nothing but 2 times sum of the factors, because finally when we say sum of the perimeter, that means 2 times length plus breadth. Okay, that means this only. And we very clearly said that A is greater than B. So there is no chance of double counting. Okay, so if you have 2 in 2160, for example, if you have 2 into 1080, you won't have another field with 1080 into 2. If that also was allowed, then you will have to do further double of this. Okay, but this condition very clearly restricts you from doing that. A is always greater than B. So that's how we are writing this. So your answer is 14,880. Okay, fine. Let's move on to the next one. This is the fifth formula now. Product of factors. Okay. What is the product of all the factors? Again, this is a very simple formula. The product is nothing but n number itself raised to the number of factors by 2. Okay. So if I take number 60, 60 was equal to what? 2 square into 3 into 5, right? So if I ask you what is the product of all the factors, then it is going to be 60 to the power number of factors. How many factors does this have? 3 into 2 into 2. It has 12 factors. So 12 by 2, that means 60 to the power 6 is going to be my answer. As simple as that. Okay. So if I look at a question here, what is the product of all the factors when n is equal to 2160? So 2160 was equal to how much? 431. So total number of factors is equal to 5 into 4 into 2, right? Which is 40. So my product of all the factors is n to the power 40 by 2, which is n to the power 20, right? Hence the answer will be n to the power 20. In the third option 20 is missing, so we'll put 20 here, and this will become my answer for this question. Okay, what formula we have used? Formula was given here. It is n. Okay, product is always n, the original number, to the raised to the power number of factors by 2. Okay, so here also the original number is 2160. Okay, so 2160 raised to the power 40 by 2, or 2160 raised to the power 20. 2160 is nothing but n, so n raised to the power 20 becomes my answer. Okay, let's look at the sixth formula, number of co-primes. Now this is something very important and is useful in a lot of other questions also. Number of co-primes to n less than n. How do I find that? And I'll take a small number to show this to you. Let's say my number is 24. Now 24 is nothing but 2 cube into 3. Now I want to know what are the numbers less than 24 which are co-prime to 24. Now if you see, 24 is a multiple of 2 and it is a multiple of 3. So all numbers less than 24 which are not a multiple of 2 or a multiple of 3 will be co-prime to 24. What are those numbers? 1, obviously 1 would be there, 2 will not be there, 3 will not be there, 4 will not be there because that's also multiple of 2, 5 will be there, 6 will not be there, 7 will be there, 8 will not be there, 9 will not be there, 10 no, 11 yes, 12 no, 13 yes, 14 no, 15 no, 16 no, 17 yes, 18 no, 19 yes, 20 no, 21 no, 22 no, 23 yes. These are the numbers. You can see that all of them incidentally are prime numbers, though that may not always be the case. You may have some composite numbers as well, but here that is not the case. Okay, so I get total of 1, 2, 3, 4, 5, 6, 7, 8 co-primes. Okay, this we have done manually. Formula wise, the formula says that basically this is, and what is the logic? Let's understand. Let me list down all the numbers from 1 to 24. Okay, so what the formula says, that every second number will be a multiple of 2. See here again, power does not matter, so you can forget the power. Every second number will be a multiple of 2. So when I do 1 minus 1 by a, which means 1 minus 1 by 2, I am removing every second number and I am taking the balance. Okay, so n is 24. 24 into 1 minus 1 by 2 is 24 into half, which gives me 12 numbers. So every second number which is every even number has been eliminated. So I eliminate all the even numbers. So out of 24, 12 numbers are eliminated. I am left with only 12 numbers and all these are odd numbers. So all the multiples of 2 are gone. Now from the balance, if I remove every third number is going to be a multiple of 3. You can see here, let me use a different color. This is a multiple of 3. Then after this, first number, second number, third number is again a multiple of 3. Then first number, second number, third number is again a multiple of 3. Again first, second, third number is again a multiple of 3. So earlier also every third number was a multiple of 3. Right now also every third number, because the pattern is same. So if I remove every third number, how do I remove every third number? And take the remaining 1 minus 1 by 3. 1 by 3 would be every third number. Balance would be 1 minus 1 by 3. Okay. So I get 12 into 2 by 3, which is 4 into 2, 8. Okay. So these numbers are also removed. Now if you see what is left out, it will tally with what we have here. Okay, you have 1, we have 5, we have 7, we have 11, we have 13, we have 17, we have 19, and we have 23. Okay, so this is what is the formula, and it is denoted by this symbol which we can call phi, that n is equal to n. Your total number of coprimes is equal to n into 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c, and so on. This formula also has nothing to do with the power. It only has to do with ABC. Okay, and this value is called as phi. And there is a related formula also. Let's do that also. Then we'll go to questions. What will be the sum of all those coprimes? We found those coprimes. Now what will be the sum of all these coprimes? Let's quickly add all of them to see. 1 plus 5 is 6, 6 plus 7 is 13, 13 plus 11 is 24, 34, 37, 47, 54, 64, 73, 83, 93, 96. You get the sum as 96. Okay, there's a very simple formula to give you this, which is basically whatever we found earlier. We found 8, right? You multiply that with, what was your number? 24, right? 24 by 2, which is 12. So 12 into 8, you will get the same 96. So if you have to find the sum, you have to do nothing but find the number of coprimes and just multiply that with n by 2. And you'll get the sum of all those numbers, all those coprimes. Okay, let's see here. For the number 2160, so again we have 2160, which was how much? 431? Yep. 2 to the power 4 into 3 to the power 3 into 5 to the power 1. How many coprimes are there? 2n less than n. So phi will be equal to 2160 into 1 minus 1 by 2, 1 minus 1 by 3, and 1 minus 1 by 5, which is 2160 into half into 2 by 3 into 4 by 5, which gives me 2 gets cancelled here, 3, so you'll have 720, and 5, you'll have 140, how much? 144. Okay, so 144 into 4, that will give you 100 is 400, 560, 560 plus 16, 576. So there are 576 numbers less than n which are coprime to n. Obviously, you don't have so many primes, so a lot of them are coprimes. Because see, just understand logically, anything which is not a multiple of 2, 3, 5. For example, number 7. 7 is a prime. Okay, but 7, if it gets multiplied with anything other than 2, 3, 5, So 7 into 11, 7 into 13. So numbers which are multiples of prime would also be co-prime to this. Only thing is they should not contain 2, 3, 5, that's all. Okay, so you will have 576 numbers. Okay, what will be the sum of all those numbers? Sum will be 2160 by 2 into 576. Okay, or 1080 into 576. I'm not going to calculate this, but you know that this is what is going to be the answer for this question. Okay, so this was all that was there in factors, 7 different formulas. We started with number of factors, then we looked at pair of factors, then we looked at pair of co-prime factors, then we looked at sum of factors, we looked at product of factors, we looked at a number of co-primes to n less than n, and we looked at sum of all those co-primes. Okay, so these are the 7 concepts, very, very heavily used and asked in each and every exam. So be very, very clear with the formulas. And we also discussed a lot of variations. Okay, so please revise this thoroughly, do all these questions, and do as many questions as possible from your exercise material so that you are completely on top of this. Okay, great. Thank you so much for being with me, being patient in the class. And in the next class, we are going to touch upon the concept of cyclicity and factorial. Again, 2 very interesting and exciting concepts. So stay tuned. Nishant here, signing off. Thank you so much. Bye-bye.